These are the 10.8 notes for trig. We're going to be raising a complex number to a power today. So in order to raise it to a power, you're going to take r to that exponent. Right, so whatever the exponent is. And then you're going to multiply the n, and the theta. So the exponent times the theta. All right, so for example number 1, find z squared. So z is going to be the n, and we're going to take 4 and raise it to the power of 2. And then we'll do cosine of, I guess I should have made that a bracket. There we go. All right, cosine of the exponent, 2 times the theta, pi over 6. Plus I sine 2 times pi over 6. All right, 4 squared is 16. And then I'll put 2 over 1. And 2 over 1 times pi over 6. I can cross cancel the 2 and the 6 to make 3, which will get me pi over 3. And then, of course, the same thing happens over here. And you're all finished. Now, one thing to make sure at the end, you do have to make sure that your answers fall between 0 and 2 pi. So as long as your number is between 0 and 2 pi, you're good. If you can't tell, just take the 1 here and divide it by 3. And 1 divided by 3 should end up between 0 and 2. It'll make more sense on the next one as we do it together. So for example number 2, it says calculate, and they notice they give it to you in a different way. That's still going to be our n, and that's our r up here. So we're going to take radical 2 to the 4th power, and then we'll have cosine of 4, the exponent, times 8 pi over 5. I sine 4 times 8 pi over 5. And then we're going to multiply. So when you have radical 2 4 times, I want you to think about it as radical 2 times radical 2 times radical 2 times radical 2. Each of these radical 2's together would get me a regular 2 and a regular 2, and then 2 times 2 to make the 4 in front. So 4 cosine, and then I'm going to multiply 4 over 1 times 8 pi over 5, which will get me 32 pi over 5. 32 over 5 seems like a pretty large number. Seems like it's a number bigger than 2. So if I do 32 divided by 5 in my calculator, I actually get 6.4, and that's larger than the 2 that we need. So what we'll need to do is we'll need to subtract 2 pi from this. When we do that, we'll need common denominators. We'll use a 5. 32 over 5 will stay. Multiply that by 5 to get 10 pi. And then we can subtract that, getting us 22 pi over 5. In order to see whether that's small enough, you do 22 divided by 5. That's still 4.4, so you subtract it again. The good thing is once you've gotten common denominators once, you could use that as your common denominator again, and you just subtract out another 10. So then that would put you at, I'm going to go this direction, 12 pi over 5. 12 over 5 is still too large, so you subtract 10 again to get you 2 pi over 5. And 2 over 5 is small enough. That's 0.4 in the calculator. So we'll write our final answer as 2 pi over 5. I sine 2 pi over 5. And there we go. It's just a couple little extra steps that you'll need to do at the end. Let's try example number 3. Calculate the square root of 5. Cosine pi plus I sine pi raised to the 8th. So there's our 8. That's our n. Here's our r, and of course our theta. So we'll do the square root of 5 to the 8th power. Cosine of 8 times pi plus I sine 8 times pi. All right, so you have 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. And if you can logically think your way through this, that would be a good time to do it. All right, so that makes a 5, that makes a 5, that makes a 5, and that makes a 5. All right, so we have 4 5s. 5 times 5 times 5 times 5. I'll type that in my calculator. Gets me 625. Your calculator should also be able to do that if you just type in the square root of 5 raised to the 8th power. All right, and then we have the cosine of 8 pi, which is obviously going to be too large. We need it to be less than 2 pi. So I'll take 8 pi and I'll subtract 2 pi. This time is nice. I don't have to get common denominators because there are no denominators. That gets me 6 pi, too big. Subtract it out again, gets me 4 pi, too big. Subtract it out again, 2 pi. And notice right here, I actually want it to be less than 2 pi, not equal to. So I'm going to subtract 2 pi one more time to get me 0 pi, in other words, 0. Remember, 2 pi and 0 are technically the same place if you think about your unit circle. I'll flip over to this paper right here so you can see it. All right, if we look at the 0 and the 2 pi, it is the same location, but we're just going to make sure that we use the 0. Right, so then we have cosine of 0 plus I sine of 0. And there's your final answer.